Okay, so chapter 6, section 1, we're talking about using similar polygons. So in this lesson, we're going to talk about any type of polygon. It could be a quadrilateral. When we get into lessons 6.3 and 6.4, we're going to narrow it down to triangles. And remember those shortcuts we use to prove triangles congruent, like side, 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 and those different things, side, angle, side. We're going to learn some similar shortcuts to prove polygons similar. So what we need in order to prove or show that these two polygons are similar, we have to show that all corresponding angles are congruent and all corresponding sides are proportional. Okay, the sides are not going to be congruent, only the angles. So the sides will form proportions. So, for example, if you weren't given a similarity statement, and a similarity statement is this statement right here. Back in the other chapter, we learned the symbol for congruence to be the equal sign with the squiggle on top. The symbol for similarity is just the squiggle. So this little squiggle in between these capital letters A, B, C, D, that statement is your similarity statement, and it's saying that polygon A, B, C, D is similar to polygon M, N, O, P. Now, we can match the letters in the positions that they are, and we can see that the first letter A matches with the first letter M in this one. And this is how we can tell the corresponding angles. Now, if we weren't given a statement, we might be given pictures. And in the picture, they're going to have the little tick marks or the congruency marks. So we could see that A and M have the same marking. And then we could add 2 to the B and the N. And then we could add 3 to the C and the O. And then we could add 4 to the D and the P. So if you weren't given the statement that said that A, B, C, D was similar to M, N, O, P, you would look for markings in your picture. Now, we would also have to make sure that all of the sides were proportional. So for example, if I added numbers to my picture, so let's say I put in 8 and an 8 and a 3 and a 4. And then, sorry, wait, let me change this to let me change this and make this 4 and this 6. So then over here in the smaller one, I would put a 2 and a 3 and a 4 and a 4. So now what I'm going to do is I'm going to match now the corresponding sides to make sure that they're proportional. Now before I had numbers, the only way that I could match them is to put them in ratios with letters. But now that I've added numbers, I'm going to fill in those side lengths and make sure they all simplify to the same fraction or the same ratio. So notice here I have side length AB is 4, and it matches with MN, which is this first fraction. So I'm going to put 4 over 2. Then I'm going to take the next fraction, the BC over NO. BC is 8 over 4. Then I'll take the CD over OP. CD is 6, OP is 3. And then the last one, the AD, which is 8 over MP, which is 4. Notice all 4 of these ratios, or all 4 of these fractions, all simplify to 2 over 1. So because all of the sides are proportional, these figures are similar. Yes?
What's the symbol for similar?
The little squiggle here. So the one above it meant congruent. This one means is similar. And the scale factor is what we're going to see on the next slide. So if two polygons are similar, then the ratio of the corresponding sides of two similar polygons, that turns into the scale factor. Now, first thing you need to do is make sure that the sides are congruent, or the angles, sorry. The angles must be congruent in order for the triangles to be similar. If you do not have congruent tick marks or symbols, then you can't show that the figures are similar. So first thing we're going to look, notice that all angles, all three in each triangle have the same markings. So these are actually equilateral triangles. And they're also equiangular, because notice the sides. This is a smaller equilateral and this is a larger equilateral. But if I were to take all of the corresponding sides and match them up, I could see that they all simplify, or all become 3/6, which simplifies to 1/2. So if I said, what is the scale factor of triangle ABC to DEF, you would say it has a scale factor of 2 to 1. 1 to 2. But if I said it backwards, and if I said, what's the scale factor of DEF to ABC, then you would say it was 2 to 1. Remember, there's 3 ways to write a ratio. You can write it with a colon, you can write it with the word TO, or you can write a ratio as a fraction. 3 ways to write a ratio. The order of the letters that's given to you matters. Any questions on this slide? Anybody still need it? Okay, let's look at the next one. Okay, here's our first example. First thing they want us to do is find the scale factor. In order to do this, I need to find the 2 sides that have numbers. So let's look at our statement here. We have ABCD to MNOP. So if I take the first 2 letters, the AB, and I see that it matches with MN. So if I put AB over MN, I end up getting 12 over Y. I need to have a number in the top and the bottom. So right now I still can't get the scale factor because I still have an unknown. What if I take the next 2 letters, the BC and the NO? BC is over here, and then NO. So if I take that BC, it's 4, and NO is X. I still don't have enough. So this is BC and NO. Then if I go around, try to match this one with this one. So notice the DC or the CD is the last 2 with the last 2 here. I'm still at 14 over Z. I still don't have a complete ratio. Let's go to the last one. Now you don't have to go through this and show all of this. If you can see right away that AD matched with MP and it had the numbers, there's your scale factor. Okay, I need to simplify that. What can I reduce that ratio to? 5 to 4. I can divide them both by 2. That is my scale factor and the answer to part A. For part B, I really didn't waste my time by setting up all these fractions because I've got my first part of my proportion. Now, to get the other half of the proportion that I'm going to solve, it's going to be this scale factor. So over here, I'm going to turn these into 3 different problems. I'm going to set this equal to the scale factor, each one. And this is how I'm going to find that missing side length. Now, sometimes they're going to be nice and pretty and you can see what it's being multiplied by, but these are all going to end up being mixed numbers or decimals. When you're looking for a side length, you must divide it. You cannot leave it improper. Everybody hear what I just said? So when you're looking for a side length and this is what I'm looking for x, y, and z, I cannot leave it improper. After I solve these proportions, I have to divide. Okay? For the scale factor, you can leave it as an improper fraction. That's okay. But not for the side lengths. All right, so let's go ahead and solve these three proportions. This is where I'm going to do the cross products. We're referring back to our Algebra 1 skills here. 5 times y, 12 times 4. So I get 5y equals 48. I need to divide by 5. And y equals 9 3/5. You can leave it like that, or you could also make it 9.6. So either one of these two would be acceptable on the quiz. Okay, the next proportion will be to find the value of x. Again, cross products. 5 times x, 4 times 4. 5x equals 16. Divide by 5. X equals 3 1/5, or 3.2. Everybody good on making an improper fraction into a mixed number or a decimal? Anybody need me to show you the division on that? All right, then the last proportion to find the value of z, again, cross products. So 5 times z, 4 times 14 is 56. Divide by 5, and z equals 11 1/5, or 11.2. Good so far? All right. So that's how we can find the value of x, y, and z, is to solve the proportions. Now we have to find the perimeter of each one of these figures. How do I find the perimeter of any shape? Add it all up. So I'm going to first add up A, B, C, D. And from A to B is 12. B to C is 4, C to D is 14, and A to D is 10. So I'm going to add all that up, and I get a grand total. My perimeter of this larger shape is 40. Now I have to do the smaller one. Good thing I made them decimals. It'll make it a little bit easier to add up. So let me go ahead and add up the MNOP. So I actually have 8 for the one that was already there. Then I have 9.6, 3.2, and then 11.2. Gonna add these up. And I get 10, 18, 22, 32. So the perimeter of this one is 32. So it first said for part C, find the perimeter of each. I've done that. Now it says to find the ratio of the perimeters. So again, ratio is a fraction, or with the colon, I'm going to write 40 over 32. What will that reduce to? 5 to 4. Notice the ratio of the corresponding sides, or the scale factor, is the same as the ratio of the perimeters. The next slide is going to show us the theorem that's going to reinforce that. So the ratio, or the fractions, for the corresponding sides, the scale factor, and the perimeters are always going to be the same ratio. It's 5 to 4 on this one. So here's our first theorem from chapter 6. Again, you don't need to know that it's called theorem 6.1. Know that it's called the perimeter of similar polygons theorem. So this theorem states that if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. And we just demonstrated that. Once we found the perimeter, added it all up, and then simplified the fraction, it was the same as the scale factor, or same as this corresponding side lengths. Does that make sense? And that this is it in the symbols. So we just demonstrated that the scale factor and the ratio of the corresponding side lengths is the same as the ratio of the perimeter. One more slide. Okay. Here, similar polygons. Now, before it said about the corresponding side lengths and the perimeter, now it's just saying the other thing, that if two polygons are similar, then the ratio of any corresponding lengths in the polygon is equal to the scale factor. So scale factor ratio, corresponding side length ratio, and perimeter ratio is always the same. What can I do to find the length of this altitude? Now, we're referring to triangle TPR, which is here. That line, I think it's just part of the, oh, sorry. Oh, that was on the other slide. Okay, so for this one, we're referring to these two triangles, not the smaller right triangles. So, how could I find the length of this missing altitude here? What do I need to do? What if we find the scale factor? How can we find the scale factor? Okay, what is it?
8 over 6.
8 over 6. Actually, we're going to, let's do it the other way. Let's do from the smaller to the big. So I'm actually, since I'm not talking about the smaller individual right triangle, I'm going to add the 6 plus 6 and get 12 over 16. Does that make sense? So 6 plus 6 for the TPR and 8 plus 8 for the XPZ. The scale factor here, when I simplify this, becomes 3 to 4. Now how can I find the altitude if I know the scale factor? I can do a proportion, right? I'm going to name the altitude, I'm just going to give it a letter. I'm going to say it's x. So I'm going to do 3 over 4 is equal to x over 20. Cross, multiply, and divide. Now, can anybody look at this without doing the cross, multiply, and the divide and tell me what x is? 15. Because notice here, if I times this by 5, I can times this by 5 and get 15. Sometimes they're this nice and pretty, and you can see it right away. Otherwise, what never fails is this cross product stuff. So 4 times x, 3 times 20, divide by 4, and I still get 15 by doing it the long way. If it's that obvious and you can figure out what we multiplied the bottom by, I'm okay with you doing that to the top when it's nice and pretty like this. The other one had decimals, it wasn't pretty. Okay, so remember, in order for figures to be similar, the angles must be congruent. They need to have the same kind of tick marks or congruency marks. However, the sides are proportional. They must simplify to the same fraction. So your homework tonight is the practice B. You have 25 minutes to get started on it. I highly recommend you start on it now because I can already see that people are tired because your sleep pattern is messed up because probably a lot of you didn't go to bed till super late. So work on your homework now so you don't have to take a nap and you can go right to bed. So,